Hello YouTube. Today's video is actually really cool. This is something that I've presented actually quite a few times. However, I strongly believe that this work here that I'm going to show you is ready. There's one piece I'm going to talk about that needs a bit of work, and that's coming up in the next release after we finish this current release. So today's discussion is around big IP multi-cluster for Kubernetes. And so we've talked about this, as I said before, but I think right now where we stand, we're ready. And the reason why I say that is because we've been working with some customers, some internal sales folks, but mostly some external customers that have actually been doing quite a bit of testing, providing a lot of feedback. And to those folks, I really appreciate everything, all the feedback. As you might know, this solution for on-prem, there's not a lot of vendors, there's not a lot of organizations that provide this kind of multi-cluster solution, specifically with load balancing or ratio distribution of traffic across Kubernetes clusters, especially with making things as simple as possible. And so that's what we've been doing over the last year, simplifying the environment, making this super simple, and listening and providing lots of feedback. And there's one other piece that's coming. I'm going to talk a little bit about it today. One other piece that's coming in the future. So this YouTube demo and GitHub really demonstrates how to use, F5 Big IP for your multi-cluster Kubernetes environment. It doesn't matter what flavor of Kubernetes. It could be Rancher. Rancher's being tested in multi-cluster. It's working amazing. It could be OpenShift. It could be just vanilla distribution of Kubernetes, which is what I'm using here. I'm using Rocky Linux on top of a Kubernetes 3.1, and it is awesome. Absolutely flawless. I haven't seen any problems over a week of doing this testing. Kudos to whoever works on that flavor of distribution. It is amazing. Made my life so much easier. As a product management, I don't have time to troubleshoot this type of stuff. It takes long enough to get this stuff installed and working. So this solution, as I said, has made tremendous progress over the last year. We released this a year ago. Currently, right now, it's focused on classic Big IP. However, once we finalize this, get some customers in production, get some more user experience back, what we're going to do is we're going to move that functionality into Big IP Next. So Big IP Next for Kubernetes is kind of where it's going to show up next. I'm not sure if it's going to be CRDs or if it's going to be Gateway API. We'll decide that at the time. That's going to be next year, August. Probably Gateway API, to be honest with you, with a gateway type of deployment. So again, for the testing, the progress that's been made, I believe that, and that's not just me, I believe now that this is now ready for prime time, right? So you can start to deploy this, bring your application clusters. This is fully supported, fully baked, fully supported. There's multiple options here that you can use. There's multiple methods, multiple modes. Really, you're up for for you folks to kind of pick and choose how you want to customize this. I'm going to give you the most simplest, explicit definition of multi-cluster Kubernetes out there. Honestly, you can install this in an afternoon, get everything running. It's super simple. So in my environment, I have 3 Kubernetes clusters. Like I said, these are brand new 3.11 clusters. Everything is installed from scratch. Now, in my clusters, the clusters are the same, but this architecture is defined that you explicitly define the cluster, the namespace, and the service, which means it's kind of nice. I could have used different namespaces, different clusters, and different services, and it all could have worked. So, for example, namespace could have been cluster-based, right? So it could have been cluster 1, namespace 1, service 1, cluster 2, namespace 2, service 2. I could have done that. That actually is pretty trivial, and this solution still would have worked. And I'll show you why. It is that well designed, and a lot of thought in that. And there's a couple of folks that pushed hard for this, and it's in the product. So the next is that I'm just using Flannel. I mean, why not? You can use Calico, you can use Cilium, you can use ovn-kubernetes, you can use Antria. It all works. And not only does it all work, it doesn't require any manipulation or any CNI changes other than the unique pod addresses. If you don't want to change the pod addresses, then just use node port. But that is of the coolest, is because CIS plumbs the routing table. Right? Very simple big IP routing table with static routes. Okay, and it only plumbs the routing table where there's active services. So for the primary and secondary CIS is running, it's going to automatically create the routes. But where there's not services running, it won't create the routes. But if you've got active services, it'll create the routes, right? So for cluster 3, there's an active service there involved, it's going to create the route. If there's no service, it'll remove the route. So the routing table configuration is fully dynamic. If there's a node in place in that cluster, it'll create the route. If there's no nodes, it won't create the route. If there's updated nodes, it'll update the routing table. This is the absolute best. And so you don't have to worry about mucking with the CNI stack. You don't have to worry about getting licenses for external product or implementing BGP or bringing in advanced networks. Not necessary. Everything can be done just with one or two simple arguments within CIS. And so that is the difference. No tunnels, no manipulation with the CNI stack. The only thing you have to do is deploy unique Kubernetes pods. And that means that when you install Kubernetes, you change the CIDR stack. So 10.244, 10.245, 10.246, for example. So that is of huge importance. You pick your CNI, Flannel, Cilium, Calico, OVN, or Entree. All works. Ratio distribution between the Kubernetes clusters with a simple CRD. Okay? In this case, it's transport. You can use virtual server. That's fine too. Right? That'll be supported in 2.19. Right? So transport or virtual server. It's up to you. It's very simple traffic load balancing between the clusters, which is done through weights. I'm going to distribute and show you the distribution of weights. Service type load balancing is coming next. Folks, this is fully baked. This is fully cooked. I'm just waiting for the code. So my team, I want the software. I was hoping for it last week so that I could present it this week. But they're just finishing it up. So I give them time. I know they've got a lot going on. So I know they're doing it well. And I really, really, really love what they've done. So we're able to do service type load balancing for multi-cluster Kubernetes. It's huge. Again, you'll get your demo. Promise you get your demo first or second week of December. So the other thing is we're keeping the ingress simple. No hacking away, right? No additional licenses other than just standard big IP. You just need standard big IP LTM. That's it. That's all you need. One hop away or sitting in front of the cluster. You can do big IP HA. That's no problem. We're just using simple routes, right? So very simple way of doing this. Or just, if you want, you just use one cluster and then just replicate the traffic. Just use configuration sync or some kind of synchronization from one big IP to the next. No problem. But most of the environments, there's multiple big IP clusters in these environments. So again, we talked about the static routes, and I've already demonstrated this, but the static route deployment is 2 arguments. In this case, I'm using Flannel, but you can change to whatever CNI stack. Probably in the next demo for service type load balancer, I will change the CNI stack to Calico, just to kind of keep things interesting. You can see here's the static routes for my environment. I have a 244, 245, 246, 244, 245, 246. So 244 is cluster 1, 245 is cluster 2, 246 is cluster 3. You'll see that because as I distribute the traffic, you can kind of see here I'm connecting to the virtual. This is the external public IP, whatever's hosted there. You can see in this environment, where am I going? I'm going to 10.244.1.3. This is the first cluster. It's cluster 1. And so if I look at why I'm going to cluster 1, I can look at my configuration here. And so what I'm going to do is I'm going to refresh on the transport server, which is and you can see here it's all 50-50. So it's an even distribution across all the clusters, right? So it's kind of like even Stevens here. I'm going to go manipulate these weights in the example for you, but I'm going to leave the repo as 50-50-50 because I'm going to actually VI and apply or make a change to the transport server. So that is the very simple static routes. You can see the static route implementation going on there through the imperative API. So let's talk a little bit about primary and secondary CIS. Okay, so we have this external config map, and we use this external config map kind of like our gateway configuration for Classic during CRD's non-gateway API. And so we have this spec that's something called high available CIS. So high available CIS is basically, in this case, the CISs are kind of like keeping health of each other. So there's a monitor or some type of health connection API between the two, right? And this could be either externals, could be big AP, something like that. In my instance here, I'm just using an external server, to be honest with you. Now, this is not perfect, right? This is not perfect because if the two CISs, for example, cannot reach or cannot communicate, you're going to have a problem. We totally understand. So we are reworking this in 2.20. I want to introduce some kind of open API where that open API basically tells and provides CIS its state, and the state doesn't change unless it's advised, or it cannot. It is a mechanism where it knows that the primary is not there and the secondary needs to change. So we're working on this. We've done multiple design sessions, multiple whiteboarding sessions. We've got a lot of feedback from different organizations. So in 2.20, we're going to rework this, and so you won't have this problem. But for now, you're perfectly fine implementing this. Just understand that there's a little bit of challenges. But honestly, by the time you guys put this in production, you'll be at 2.20, which will probably be early next year. And so we will have this reworked. Maybe this high availability here won't have primary cluster and secondary cluster. Might not need it anymore. All we really need is just really the endpoint, this primary endpoint right here. That's probably all we need. And I'm thinking that there's quite a bit of really cool things that we can do there. So I'm going to leave it at that for now. But as of now, you need a primary, and this is your primary CIS, your secondary CIS, and then this external config map is deployed in the primary cluster and the secondary cluster. CIS is deployed in the primary and the secondary cluster. And the only difference is in the CIS implementation or the CIS configuration file, you kind of specify what's the state. So if we go and take a look at cluster 1, if we look at the CIS deployment, you'll actually see here in this deployment, I didn't show you this last time, this is a multi-cluster mode of primary, which is kind of cool, which this probably won't change. Here's the config map, so you can see these two arguments here. If we go take a look at the second cluster, in the second cluster, here you see CIS. It's the same files you see here in the second cluster, same file. The only difference is that the CIS is running in secondary, and that's the only difference. And the difference being primary and secondary, honestly, the only difference is it's what CIS posts the configuration file. Just so basically both CISs are not posting or sending an update to the big AP at the same time. That's the only difference. That's the only difference. Other than that, CISs are identical. Which is actually not that much of a problem if both CISs do that. It's just double hits on the API. And so just to eliminate the APIs, it's just we only really want one CIS updating the big AP. And so the primary is the only one that's sending the updates. The secondary is just really waiting if it becomes an active cluster. That's the only difference. Or you could move it around. If you don't want to use primary, secondary, you can use standalone. Standalone CIS would be, you basically deploy CIS in like a management cluster. It works really well. So standalone CIS is kind of nice as well. I demonstrated that on my previous videos, where we only have one CIS instance and maybe it's running in a control plane cluster, for example. So that's another idea, to use the standalone CIS. And so let's go ahead and take a look at the ratio of the traffic. So we talked about this earlier. So in this case here, we're using a simple transport server CRD to manipulate traffic between the clusters. Simply change the weight in the CRD to present the desired load balance distribution by big IP across the clusters. Really, that is as simple as it gets. And this is why it's explicit. It is default mode. It's not ratio mode. This is default mode. And so you can see it's of namespace default. So when I talk about default mode, we're actually running CIS in this what we call default mode. And so that's really important. So it's a new mode that we just developed for a specific customer. When you're using default mode is nothing is assumed. So it's not ratio in this case, it's not an A/B. And default mode is kind of where your services might be a little different in each cluster. Or maybe it's a Windows cluster and one cluster is a Linux cluster, for example. So the clusters are slightly different. Or maybe it's Kubernetes versus OpenShift, and some things are different. And so therefore, when you do default, you explicitly define all of your configuration. And it's the same thing for service type load balancer. And so in this cluster here, you can see cluster 1. In this case, it's all the same. But like I said, it can be different. It's explicitly defined in default mode. We don't assume anything. So we made a lot of assumptions initially when we did multi-cluster, because we thought that the assumption would be kind of like active standby or an active-active ratio. But that's fine if the two clusters are rolled out the same. But if the clusters are different, then that might not be the case. It might be that there might be some legacy apps that have different services or different names, right? Maybe one cluster was deployed earlier and the second cluster is new, but they've updated the manifests and the naming conventions are slightly different in the second cluster. And therefore, you would use default mode. I highly recommend moving forward, use default mode, because I think default mode makes a lot more sense. It's a lot more fine-grained. So we actually have 4 modes. Standalone, which is kind of like using like ratios or something like that. We have default mode, which you can use standalone. We have a couple other like A/B type modes as well. And so this specific mode that we're using here is type default, and this is defined in the extended config. And so you will see more of this, and the documents will explain the differences. But we're testing all modes, automating all modes. You pick and choose what you want. That's why I think we've done so much work now around this, and this kind of like makes sense. This is specifically written for a customer that wanted to have explicit services with their multi-cluster service. Right? So this is kind of what it looks like, and this is kind of finished, and applications are starting to roll into that environment. That's why I'm saying it's ready for prime time. So let's go ahead now, and as we said, let's take a look at what this big IP looks like. So we've got a big IP that we need to log back into. So the big IP has a transport server deployed, and that is in the K8s deployment, and you can see that all the pools are happy, and that we have this big IP right here, and very simple configuration. You can't really see much, but if we go to statistics, you can probably see on the virtual server statistics. Yeah, you can see there's not really much going on here, but yep, I can increase the communication here if I want. Just simple web browser. I need more traffic. I need quite a bit of traffic to actually see something nice. Yeah, it's all going to 10.244, and the reason is because I've manipulated the transport server. So let's go and take a look at that transport server, and so you can see. Look at that. Yeah, it's 100 zeros. So for example, let's go and change this to, how about we make this a 50-50 split, and so make this a 0, and how about we make this second one here 50 and the second one. So why would you want to do this? Well, think about how great this would be if I could just go and say, hey developer, okay, take app 1 down. Don't worry developer, I've got your application 2 and 3 in cluster 2 and 3. I mean, how awesome would this be? Now I could actually take that entire cluster down for maintenance. And I think that is the biggest challenge here. This is kind of like why we're doing this. So I'm going to go and apply. So you apply that from the Kubernetes environment. If you want to, you can watch the API. You don't have to. I'm running this in debug, so it's not recommended using debug. But there I saw the configuration was applied. You can see it right here. This is the API call, and there is the information update. So, yep, I'm doing a bit of debugging here because I'm just testing. But so that configuration has actually been applied. And so what you will see now is with my very simple app here. You can see I'm at 245.1. Now I should see some potential with some refreshes, and maybe here, even if I actually open there should be no persistence here because this is basically a transport server. But there you go. See, 246 and 245. So you can see the distribution across the two pools. So it's right even split, 246, and I should not see 244 at all. You won't see it. So even if I open another one here in the browser, you will never go to 240. You'll never go to 244, 10.244. Now, the cool thing is that 244 is still online. It's just not receiving any traffic, right? You can see that I haven't actually failed if I go to the pools here, I haven't actually failed the monitors, right? So the monitor is still healthy. So those two members are active. It's just big IPs, not ratio, and I'll send in any traffic there because you changed the ratio on the weight, right? So what does that mean? That means that I changed this weight, right? This weight is of 0, and right here, this is 50-50. So based on that weight and how I distributed the weight is kind of how the traffic is getting distributed across the cluster. Guys, this is very cool. This should be standard for all of your virtual servers, transport servers. This implementation right here should be standard, right? You should be able to distribute it across 2 clusters. Honestly, it's not that hard. If I can do it, anybody can do it. And I'm a product manager. So we'll go ahead and drop this back to 0. And how about we change this to 100%? So this is kind of like how these weights are working right here. And so we'll save this now. And we'll go ahead and give this about a minute to apply. I mean, you could. Honestly, it's done much quicker than that. The API is very simple, but again, the system is not busy. So if it was busy, a little bit busy, if there's multiple stuff going on, take a little bit longer. But so that's the very simple change there. And so we'll go ahead and update that. 246 is updated. 246.3 and 246.3, and I think there was one more. That was 246.3. So as you can see, it's the first pool, or 246. That is pretty nice. And so I'll do that one more time. Why not? Just for fun. We'll actually take the second one offline, or not offline, but we'll reduce the weight here to 0. Now there's nothing, and we'll bring in this first guy here to 100%. So only the first cluster is receiving traffic, and the other 2 are not receiving anything. We'll go ahead and apply that. Okay, just waiting for that to get applied. So as you can see, existing traffic is maintained. So that's, even if existing traffic needs to be maintained, it will be reload bounced. There won't be traffic won't get reset. Now you can see 244. So existing traffic is really important. Yep, there, new connection, 244, and all on the first cluster. So first cluster is receiving all the traffic. So that's it. I mean, it's not much else. Not much else other than manipulation of these weights. So like I said, this should be, I think, standard for all implementations with regards to deploying Kubernetes. So if you're deploying Kubernetes and OpenShift, always think about a multi-cluster approach, whether it's cluster 1, cluster 2, cluster 3. In this case here, I'm playing with the weights to simply distribute the traffic. And I'm doing that within the Kubernetes cluster, within cluster 1. Right? So CIS makes a simple API call to change the weight. It's a simple load balance algorithm between the 3 different clusters. It's honestly, it's that simple. And so this is why I'm saying that this solution is kind of ready for mainstream. We're going to fix the heartbeat between CIS primary secondary when we release this code in CIS 2.19, which is going to be like in a week to 2 weeks from now, which will be available. It's fully production. Right, which means that it's fully supported both by F5 engineering. We partner with Red Hat, and then the operators will be updated. So that's that's pretty much that. Pretty much what I've got to demonstrate. So for everyone that likes this content, please massive thumbs up. Send me some comments. If you're not subscribed, please subscribe. I'm trying to grow the channel. This is very F5-ish. And so if you're not in F5, please share with your colleagues outside. Let me know if you want help with the proof of concept. You're welcome to fork this repo. I will provide the link to the repo. And if you want to have a discussion, just send me a meeting invite, a meeting request, email, contact your partner channels or F5 colleagues. I'll set up a quick call. So for that, I want to thank everybody again for all the testing, all the work, the development team. I want to thank you guys a lot for everything that you've done to get this to where it is today, where I believe it is now absolutely ready for prime time. This multi-cluster Kubernetes approach is ready. And so have a lovely afternoon and enjoy your holidays. Thank you so much.